A full PE packer in one C++ file with 0 dependencies. Here is TinyLoad. TinyLoad is a Windows PE packer encryptor for x64 executables, written entirely in a single C++ file with 0 external dependencies. The current version is 7.2, and the project is actively maintained. It compresses, encrypts, and protects your binaries using a custom virtual machine, and it does all of this without requiring any libraries or build tools beyond a standard C++ compiler. The developer just posted it to the open source subreddit, and it already has 176 stars on GitHub. Building TinyLoad is straightforward. You need min-gw with G++, and then you run a single command, G++ with the output flag pointing to tinyload.exe, the source file tinyload.cpp, the static flag, optimization level 2, and the silent flag. There is also a build batch file included. The project uses the MIT license, so you can use it freely in your own work. The developer notes that the README does not cover every feature, and invites you to read the code or check the changelog for the full list. Here is how TinyLoad operates under the hood. The packer takes your input executable and appends it to a copy of itself. When the packed executable runs, the stub extracts the payload, decrypts it, and executes it directly in memory without ever writing the original binary to disk. Every time you pack something, the virtual machine opcodes are randomly changed and distributed into 4 independently keyed subtables, so no two builds produce the same output. This means each packed version looks unique to static analysis. The compression layer uses a custom implementation of LZ77 with hash chain matching and a 64 kilobyte sliding window. The compression runs first, then the VM encryption goes on top of the compressed data. This two-layer approach means that any patterns in the original data get hidden by the compression before the encryption adds another layer of obfuscation. The developer included a compression graph in the README showing the data flow through the pipeline. The virtual machine is a custom 28 opcode machine that runs inside the stub. The opcodes get randomly shuffled into 4 subtables of 8 opcodes each. Every subtable is XOR encrypted with a different key derived from the payload data itself. This means cracking one subtable reveals at most 8 out of 28 opcodes. The cipher itself is a 128-bit stream cipher using rotation left and rotation right for key mixing, all running inside the VM interpreter. The payload gets encrypted with XXD on top of all of this. With the VEH flag enabled, all PE section pages get mapped as page no access. When the packed program tries to execute a page, it triggers a page fault exception. A vectored exception handler intercepts that fault, decrypts just that one page, sets the correct memory protection, and lets execution continue. A watchdog thread runs in the background and re-encrypts any page that has not been accessed in 200 milliseconds. At any given moment, most of your program is still encrypted in memory, so memory dumps only capture whatever was recently accessed. The anti-dump protection redirects 4 critical Windows APIs through wrapper functions inside the stub. Those 4 APIs are getModuleHandleA, getProcAddress, ExitProcess, and virtualalloc. After the payload is loaded, the entire import directory gets zeroed out. This means that memory dumps cannot reconstruct the import table, making it harder for analysts to understand what the packed binary does without dynamic analysis. It is a solid defense against automated unpacking tools. The repository currently has 176 stars on GitHub. The post on the open source subreddit has 0 comments so far, which means this project is still relatively unknown to a wider audience. The developer is taking a short break until August because of vacation, and version 7.3 is planned. The project is listed on the Awesome Game Security list, which means it has been reviewed and approved by the reverse engineering community as a notable tool. If you are interested in executable packing, custom virtual machines, or memory protection techniques, TinyLoad is worth exploring. The single-file architecture makes it easy to study, and the MIT license means you can use it freely. The developer has built a lot of features that are not documented in the README, so reading the source code is the best way to get the full picture. Check the link in the description to dive into the code yourself. Thanks for watching. If you found this breakdown useful, hit subscribe and let me know what you want to see next in the comments.